Hello, this is Geometry, topic 4-1, over circle basics, circumference, and area. So let's go over some basic terms. A circle is defined as all points that are equidistant from a given point, called the center. Separates a plane into three sections: the interior, the exterior, and the circle itself. A radius, you should know this, is from the center to any endpoint on the circle. And the diameter cuts across the circle going through the center. So let's go ahead and make some labels. So this right here is a radius. This line here, a diameter. C would be our center. I is an interior point, and E is an exterior point. So we have our center, interior, exterior, the radius, which only goes halfway across, the diameter, which cuts all the way across. So let's go ahead and just go over some more basics. Again, most of this you should already know. This circle we call circle Q. Alright, a circle with a dot in the middle, that's the shorthand for circle. Q, being the center point, is what we're going to call it. So some radii that we have would be PQ and QT. Since I don't have a point right here, even though there's a radius here, I can't name it because I don't have a point. Now, the length of any radius, because QT is 16, that means that QP is 16, and so are all radii. Now the diameter, if this is 16 and this is 16, then my diameter would be 2 times 16, which is 32. We have some interior points, Q, R, and S. We only have one exterior point, that would be point X, because P and T are on the circle. So this was example number 1. Now example number 2, the instructions are here, but the actual problem is on the next page, so we're going to go ahead and turn pages. Here they've given us a radius of 27. We do 27 times 2. We get that our diameter is 54. Now if they gave us a diameter of 12, we'll go ahead and just write this down, 27 times 2. We'll do 12 divided by 2, which gives us 6. They give us a diameter of 18.6, well, we'll divide that by 2. And we get 9.3. So, given the radius or the diameter, you should be able to very quickly find the other. So now, once we know what our radius and diameter are, we can calculate circumference and area, where circumference has two formulas. The first one being pi d, and the second one being 2 pi r. Now area is pi r squared. So these are basic formulas. You probably already know them. If not, they're written here. If you've forgotten them, they're also written here. They're also on your formula chart. So let's find the circumference and area of this circle right here. Well, if this is 10, that means that this is also 10. So my diameter is 10. Now to find my circumference, I do 10 pi, which is approximately 31.42. If you're worrying about how I did that in the calculator, we'll come over here and we do 10. This blue letter right here of pi, we'll do second pi, put it directly in there, Hit enter, gives us 31.415. That 5 will round that 1 up to a 2. So my circumference is either 10 pi, or we can give a number that makes a little bit more sense to us, 31.42. Both of these are correct. This is exact. This is an approximation. Now to find our area, I need to know my radius. So my radius is 5. So it is pi times 5 squared, which is 25 pi. And 25 pi is roughly 78.54. So 25 pi, which is about 78.54. And there we have the circumference and area of this circle. Moving on to example number 4. We have circle P. Well, here I have a right triangle, which means the hypotenuse is my diameter. Use good old Pythagorean theorem. 16 squared plus 30 squared equals c squared. And 16 squared plus 30 squared is 1156. We take the square root of 1156 and we get that c equals 34. So my diameter is 34. So to find circumference, it's just going to be 34 pi, which is roughly 106.81. And our area, well, if our diameter is 34, then our radius must be 17. So pi times 17 squared, and we get 289 pi, which is roughly 907.92. And so that's example number 4. Moving on to example number 5. Here they've given us a square inside the circle, and my diagonal is the diameter. Well, I know that this happens to be a 45, 45, 90. So this is x, x, and x on the square root of 2. So that means that my diameter is 8 on the square root of 2. So 8 on the square root of 2 pi is roughly, we'll do 8 on the square root of 2, get out of there, pi. Again, make sure that this pi is not part of the square root. That's very important. We get about 35.54. Now area would be half of this, so my radius is 4 on the square root of 2. So pi times 4 on the square root of 2 squared. Well, 4 on the square root of 2. Put it all in parentheses. Squared gives us 32. So my area is 32 pi, which is roughly 100.53. And so that is example number 5. Example number 6. Here we have a 30, 60, 90 triangle. This is 30. That means that x 2x, x on the square root of 3. So this is 9 on the square root of 3. That means that this one is 9. And this is 2 times 9, which is 18. So my diameter is 18. My radius is 9. Circumference would be 18 pi, which is roughly 56.55. My area would be pi r squared. So pi times 9 squared is 81 pi, which is roughly 254.47. And so that's example number 6. Example number 7, we have an equilateral triangle. If my hypotenuse is 4, that means that this is 4 on the square root of 3. And this is 8. Now, if this is 8, that's my radius is 8. Then my diameter is 16. So my circumference would be 16 pi. And my area would be pi times 8 squared, which is 64 pi. Let's go ahead and figure out what these come out to be. 16 pi is 50.27. And 64 pi is 201.06. And so that's example number 7. Okay. Here, we found the radius first and not the diameter. Okay. Moving on to some more definitions. Well, here are some words that are important. They relate to circles, and we're going to talk about them briefly now. We will use them more later. We have chords, secants, and tangents. Well, a chord is any segment whose endpoints are on the circle. Diameter happens to be our longest chord. So if you see the diameter, it is a chord. It's just a special chord. The secant is a line or ray that intersects a circle at 2 points. So secants make chords. And then a tangent is a line, segment, or ray that intersects this circle in exactly 1 point, which is called the point of tangency. So let's go ahead and look at this. This point right here, that's what we're talking about. That's the point of tangency, which makes this line a tangent. Here, we have a line who happens to go through the circle. While this point is called a chord, the whole line is called a secant. I'll go ahead and write that this is a chord. And this right here is also a chord. So secants will always make a chord. Okay? Let's go ahead and use these definitions in example 8. We want to name the following. We want to first off name the center. Well, the center of our circle is real simple. It is O. Our radii, well, we have ON, OR, and OM. Our chords would be MN and MT. Our secants would just be line MN. I'm going to differentiate the secant from the chord by putting arrows for my secant. I have one diameter. That's a chord that goes to the middle. That would be MN. Oh, sorry, this is not MN. This is MT. MT. My tangent would be PS. My point of tangency would be Q. So, most of this is old hat. You've seen it for several years. Some of the stuff on this last page was new. Chords, secants, and tangents. They're really not that hard, and right now all you need to do is be able to name them. We'll come across on how to use those in a later lesson. So, this should be a very easy assignment. Good luck on it, and have a good day.